So me here and my colleague Alexei Ceban are going to talk about game development for smartwatches, problems and solutions that we encountered when porting our games to smartwatches platforms. It was summer 2014 and Google had their event I/O. They presented Android Wear smartwatch and that appeared to be very interesting for us because we have a ton of games that we thought are gonna be natural for the platform. So we ported over 15 mobile games to Android Wear in just 1 month, and that some fancy technology allowed us to do that. And I'm going to talk about it here a little bit. And in winter 2015, 2016, which was and still is. Now we ported over 15-hour games to Tizen in just under 3 weeks, and that's thanks to our technology that is in place. Again, sorry about messed up slide. It's conversion from Mac software to PowerPoint. So here are some of the Spooky House wearable games. You can see my favorite ones are the one with the submarine and with the rails, and the one with the red and blue dots. It's only a few of the games that we have now available on the smartwatch platform. And this is Alex's hand with a rail maze game running on Motorola 360, which is one of the most widespread Android Wear watches. Yeah, as you can see, it's quite small, but it's playable. And I'm going to talk a little bit about UI challenges that we encountered when porting over our games to Android Wear platform. You obviously have small screen, you have small round screens with bottom cut like the most widespread Android Wear watch, which is Moto 360. And maybe in the future there will be other shapes of screens which are going to add to the challenge of maintaining the platform. When you do port the game to Android Wear, you encounter also technical issues, UI issues, as I said, controls, and you have to maintain one more port, which is a big hassle. And then the next step for mobile games is not simply porting them over, but creating unique content for wearable platform, which will be native and natural, not simply simple ports of the mobile games. Among the technical challenges I would outline that performance is, there is common misconception that wearables are low-performing devices, and that is not true, because they are powered by pretty powerful GPUs and CPUs, and on par with phones that were on the market a couple of years ago, like iPhone 3GS, for instance. And frame rate is the power divided by number of pixels. The number of pixels actually on smartwatches is small, so you get pretty decent frame rate in any game you port, pretty much. Also, you have to deal with network communications, and most of the time, smartwatches, they don't have Wi-Fi or 3G, and you have to do network communications via middleman iPhone, or phone, or iPhone, or Android. And the battery life. Battery life actually is not a big problem. Most of the modern smartwatches, whether you use them for gaming or you use them for other stuff, they last for a day. And you have to charge them in the end of the day. But even if you play, it's not a big issue from our experience with our games. Also, what contributes to battery life not being a problem is that sessions on the games on smartwatches are only 5 minutes, not more, because it's not very convenient to play on the smartwatch holding your wrist like this, so you play only when you have a couple of minutes. If you have more than that, you probably will pull out your phone and play on it. So that does not affect battery life as well, either, because just don't play on the watch a lot. Even if you have a lot of sessions, they won't last long. Also, what we do to further enhance the battery life is we use FPS limiter. An FPS limiter is something that lets you limit the frame rate while you're not actually doing anything in the game, when the screen stands still. Sorry about the messed up frame again. So the good FPS limiter would keep frame rate as low as possible when picture is still. You will increase it to 60 frames a second, or the maximum when you have animated objects on the scene. And you will increase it to 60 when the user interacts. And response time shouldn't be affected. So sleep thread for 1 second is not actually going to work. You have to do something smarter than that. And there are a couple of types of frame rate limiters that I could mention. The simplest one is purely sleep-based. It's simple, but very basic. It has input lag. When you start switching from low frame rate to higher frame rate, it actually gives you a lag, which is not good. They're also purely VSync based. They are used on iOS because they have set frame rate interval function. Not all the platforms have that, or analog. It allows you to create smooth frame rates, but they're fixed to these integer values like 60, 40, 30. It also has input lag. And what we do is we use a combined approach. It's VSync with update and render that are not linked together. There is some technical stuff here. If you want to dive into that, you can do that using the slides that will be available on the website. So I wanted to show what our games looked like on the iPhone. And then here, a hypothetical Apple Watch. We don't have our games on Apple Watch yet. And here is the Android Wear Moto 360. You can see that the game is the same, UI changed. We're using icons and much more simplistic controls. So when talking about games and smartwatches, you have to keep in mind that classic control schemes don't work. If you have drags in your game, you better use swipes instead of them. You should tap anywhere instead of tap on specific location, and consider using alternative input, digital crown or Apple rotating bezel. Or not actually Apple, but rotating bezel on Samsung Gear S2. So we actually merged some wearable innovation back into mobile games, such as FPS limiter, UI gestures, and simplistic UI layout. Now we use all the things that we implemented for only wearables. We use them on smartphones too. And you can see how the UI merged back from wearable game to mobile. And here, just a couple of screens of what game looks like on different platforms. It's sort of the same, but on iPhone you have some extra controls. On smartwatches you don't, but it still plays really well, even on smartwatches, even though not all the controls are present. And I'll have to skip this. I'm just going to talk about the wearable games a little bit that are designed specifically for the platform. They need to be extension of your smartphone game, not a pure port of it. They need to be notification driven, and short sessions are natural for wearables. Lifeline is a good example of direction to move into. It's a game for iPhone and Apple Watch. It's cross-platform between the two. It has naturally limited session length due to the nature of the game. And it's notification-driven gameplay. So you don't interact with the game interacts with you via notifications. And here is an example of native controls on Gear S2, how you can use them. And digital crown on the Apple Watch instead of touchscreen. And physical buttons on Pebble. They don't have touchscreen at all. Sorry for being so quick. We just have a ton of information that we wanted to give you guys. Next, my colleague is going to take over.
First of all, we have a C++ code base. We write in C++, and just a small portion of platform-specific code, like for iOS on its Objective-C or C for Tizen. And what kind of apps can we have on our watches? So we can have connected, like dependent. The application itself is executing on our handheld device, and our watch just displays the information, the current state of the application. Or we can have a separate and independent app, like our games, that is fully executed on your watch. About porting to our game engine to new platforms, usually we have to port our graphics, our file system access. We use Irrlicht engine. It's an open source, easy customizable engine written in C++. Yeah, so C++ rules the world. And the next step, we have different sound libraries like OpenAL, OpenSL, or some platform-specific libraries like Android. And project template. What I mean is each platform has its own application entry point and some application lifecycle callbacks like onCreate, onTerminate, onPause, onResume, which we should handle. The input processing, like Andrei said, it's like rotating input, bezel for Tizen or digital crown for Apple Watches. It's touch input or some hardware buttons. And we have to set all the paths and libraries which we already ported, like sound and game engine. Next step. Probably it's like a trivial question, but how do we quit the game? Different platforms has different requirements, like for behavior. On Android, we have two possible gestures, like if we have no swipes in our game, maybe just touches or some button clicks, then it's a default behavior, swipe to dismiss. You just swipe from left to the right and exit the application. And for applications which has swipes as a gameplay, we have to disable this, because you won't like if you want to swipe your item to the left and you exit the game. Yeah. So there is a requirement for long press to dismiss. You just touch a screen, wait for a second about, and then appears the UI to exit. For Tizen, which I like really much, we have a hardware button, hardware back button. And as I already started to speak about hardware buttons, we have a menu button, which we cannot override. It's a system behavior. When we press the menu button, our application is sent to background, and we see the list of installed applications. And the same behavior is for power button on Android devices, long press of power button. Oh, that's pretty much all I wanted to speak about these items. And about our code. We have our code base, as I already said, in C++, which is it's a shared code between all platforms. It is responsible for UI items, menu navigation, store items, and so on. Some download, upload code. It's like a facade, and we have a platform-specific code, as already said, for graphics, sound, file system input, app lifecycle callbacks. For Android Wear, the port was easy, as the code was the same as for Android platform. The only difference was we had to create separate project in Eclipse. You might know that on Android you cannot install applications directly on your watch. You have to install them on your handheld device, and then with the synchronization process it will be automatically installed on your watch. So we have to put our game package inside empty handheld package. And the aspect is like 81% of shared code between platforms and 19% for each platform-specific code. And what next? We have not yet ported our games to Pebble or Apple Watch, but we're thinking about it. The main constraint here for Pebble is they don't have touch input, just the hardware buttons, and the private graphics library like Pebble. So we have to add support to our Irrlicht engine. Yes, and for Apple Watch, unfortunately, the API, ObjGL API, is private for the moment. We cannot use it. As soon as they open it, we will port our games, I think, in about a week or two, because all the code is already implemented for the platforms. It will be just some specific for like digital crown code handling and so on. So waiting for our games on Apple Watch. It's a cool watch. Well, that's pretty much all I wanted to speak. I have some links for you if you like, if you will download the slides. And thank you.
What about monetizing games for smartwatches? Is it a premium model or freemium? How can you monetize such games?
We actually don't. That's a good question. We don't monetize games on smartwatches for now. Even being the biggest smartwatch Android Wear game publisher, we don't have a ton of downloads. It's only 200,000 installs. And the platform itself is very small. It's only 800,000 devices. So even being on every fourth device, we still can't monetize. It's not enough, and people are not educated to spend money on smartwatches yet. I think it's there. It will be there, but it's not there yet. So we don't monetize. We just want to how to say, capture the market share for now.